Hey guys, here's a better lecture on what even is a derivative. So if you're watching this here is probably you being all sad about not understanding what this even is. Kind of just looks like a pile of junk right now. But what we're going to do is we're going to go through and kind of construct it from scratch. So taking a look at the definition of a derivative, it might be kind of hard to make something out of it. It doesn't really look familiar in any way. But what we're going to do is we're going to break it down. We're going to build it from scratch. So we have this target of a formula that we want to build. So where we're going to start is we have to think about what a derivative is doing. So in theory, it's giving us a function of the slope of another function, or the original function, the function that we're plugging in, because you can see we have a function that we're plugging in. We have f here. So the slope, the reason that we're mentioning slope might not be too obvious, but if we start and look at the formula of slope, it might start to reveal itself. So here we just have f of x is equal to x. And what we're going to have is, if you want to find the slope of something, it might be pretty obvious right now. We just have a slope of 1. But the actual formula to find the slope is going to be, we have 2 points, and we're going to subtract one of the y's to the other one of the y's, or in other words, y2 minus y1, and then we're going to subtract that x2 minus that x1. So these are going to be a point, and these are going to be a point. And how this looks is we have 1 and 2, and this comes up, and this is going to line up with 1 and 2. And what happens when we fill this in is this is our first point, this is our first point, this is our first point, this is our second point. So we're going to take y2, or y of the second point, which is 2, minus y of the first point, which is 1, and the same for the x's. And you can see that this just comes out to 1, and we already knew this. We already knew that the slope was 1. But what we can do is we can kind of start to manipulate this slope formula in a way that it will start to look more like this. So what we can do, instead of using 1s and 2s, let's take points A and B. So how can we represent the y of what these will give out? So what's happening is this can be written as x equals y. So f of x and y are interchangeable, which means if we write f of a and f of b, that's another way to represent whatever x is outputting. So we have a outputs f of a, and b outputs f of b. So when we write the formula this way, the slope formula, remember, so if we just replace y2 and y1 with f1 and f2 and f1, we have f of b minus f of a over, and now our x2 and our x1 is going to be x2 and x1. So we have x2 over x1. You can see that, once again, this is a point and this is a point. But now you can see this is slowly turning into something that looks more like this. So you can, on this formula, you can see instead of two different variables here, like we have b and a, it's just one. But one of them is modified with a negative h. So if we kind of resemble that here, and say we have a, that was bad a, say we have a, and then we have a minus h. And it's important to understand what's happening here. So we're starting with a, and then we have some h. We don't know the value of it right now, but we're subtracting it, so it's moving us closer to 0. Correct. So that's why it's over here. And then how we can represent the points that they lead to is just plug that x value into the function. So we have f of a minus h, because that's our x value, and we have f of a, which is our x value here. So once again, if we rewrite our function, f of a minus f of a minus h over, then we have a minus our first point of x, a minus h. And what you can see is this turns into, if we distribute the minus on the bottom, we get just positive h. Let me show you. So these cancel, and we're left with positive h. So now we have this, and this looks an awful like what we have here. So you can see how we transformed the slope formula into this. But what's important about the derivative is that it's not quite just a slope formula. And what it's trying to do is it's trying to find the slope at a certain point. There's just one point. So here you can see we have 2 points, and since it's a linear function, any 2 points have the same slope here. But if we take a look at f of x is equal to x squared, you can see if we take 2 points, the line doesn't line up with our function. And what the derivative is trying to do, as I mentioned, is find the slope at a specific point. So we want to describe the motion of a function at a certain point. So like at this point, you can see that it's flat, and then at this point, it's starting to go up, and so on. At this point, it's heading down. So we want a function that describes what's happening at any given moment. So since we're trying to find the slope at a specific point, what we can do is, let's say we have a is here, and it goes up to this point. And then we have our second point, which is a minus some h at this point. So the difference here is h. So if we want these points to get closer, if we want this point to come in, we need h to be smaller. And the smallest h can be is 0. So if you know a little bit of a limit, if we have h head as close as it can get to 0, then our points are going to be right on each other to the point where they are on each other. So that's what h is doing here. So here you can notice that we have a instead of x, because we've been looking at a single point A. But if we want to make it more general and give us a function, we can have this be any x. So that is how you build this formula, or this definition. And why it's important to understand this is because when you take a Calc 1 class, you're first going to learn about limits, simply because of the fact that this function, or this definition, involves a limit here. And then you shortly go into the derivative. And then everything afterwards is going to be building off of the fact that you know what this is. So if you don't know what this is and where it's coming from, then the rest of this is going to be garbage. It's not going to make any sense. A lot of the stuff you learn afterwards is actually just going to be rules on how to make finding this easier. And what I mean by finding this is, say you have your function, you can see that you plug it in here and just evaluate it. And there's certain rules like the power rule or the chain rule or whatever rule you want. And then another part of this is just going to be applications of it. And then you might get into a little bit of integrals, but everything builds off of this. So if you're struggling in calculus, you're most likely not understanding what this actually is. So hopefully this video gave you a better understanding of what a derivative actually is, and hopefully it makes the rest of your class much easier. So thanks for watching.